Well, x times 1 is just equal to x, regardless of the value of x. If x was 55, 55 times 1 is 55. If x was 0, 0 times 1 is 0. If x was negative 2, negative 2 times 1 is negative 2. Excellent. X times 0 is always equal to 0. This is one of those mathematical identities. 55 times 0 is 0. Negative 1 times 0 is 0. 0 times 0 is 0. It always works out. X times 2 can be rewritten as x plus x. This may not immediately seem like a useful optimization. Formally, we call it strength reduction in the sense that multiplication was a stronger, harder to compute operation than addition. On some CPUs, on some hardware platforms, it takes less time, fewer cycles, less energy to compute addition than it does to do multiplication. So even though both of these have two operands and they're both binary operators, this one might be faster on many platforms. Finally, we get to the last one, and the one that probably is the most controversial. X divided by x cannot safely be replaced with anything smaller. You'd really like it to just be 1. 1 is so tempting. 5 divided by 5 equals 1. Negative 2 divided by negative 2 equals 1. It seems like it's always 1, except for this one corner case. 0 divided by 0 does not equal 1. 0 divided by 0 raises an exception. And the golden rule of Optimization Club is always keep the same semantics. If there's a possibility that on some inputs we could raise an exception, we can't rule out that exception with our optimization. You think, why would anyone want to divide by 0? You can't change the meaning of the program. You have to keep it exactly the same when you're doing optimizations. So 1 is very tempting, but it's too aggressive. There's a single case where it's wrong, so we can't use it for optimization.